Hey everyone, this is Peter Estes of Valley Cat. It's another Just a Thought Thursdays. In today's video, what I'm going to be, and by the way, this is a live version as well. Sorry about that. In today's live stream, what I'm going to show you are the 3 different ways of making a single part. And these 3 techniques, they all have their pros and cons. Some of them have more cons than others, and I will go into detail on that. And the 3 techniques that we're going to be looking at here are the layer cake approach, the potter's wheel, and the machinist approach. So let's hop on over to SOLIDWORKS. Once again, we are doing this as a live stream, so you're going to see me look over to my left screen every once in a while to see if people ask questions while we are doing this. So in the meantime, let's hop on over to SOLIDWORKS and see how we can play with these 3 different styles. So you'll see on my SOLIDWORKS screen here, I got an assembly file, and they each have, there's a different part in this assembly. And so there's the layer cake approach, the machinist approach, and then the potter's wheel approach. If you saw our last Tech Tip Tuesday live edition, I showed you guys how to do the revolve function. And that's kind of what you also call the potter's wheel approach. So looking at this, we're going to see that every single one of these parts look identical. They were all made in a different fashion though. And like I was saying earlier, there are pros and cons to each one of these styles. Some of them do have a couple more cons than the others though. And so I'll try to give an unbiased approach as much as possible, but I do lean towards one of these functions more than the other. So let's look at the first one, and it's called layer cake approach. So I'm just pushing Control Tab to switch to that part file. That's how you can switch between files within SOLIDWORKS. So the layer cake approach, how this is determined is you build a feature off of another feature. And what I mean by build off of another feature, it is based off of building it off of another planar face of an existing feature. So we are making 2D sketches, and every single one of these features are standard extruded boss base. And so with these sort of features, it's the most common style of modeling, and also as you are introducing yourself into SOLIDWORKS, it's actually the most standard way to go. But as you advance through SOLIDWORKS, you'll start learning these other techniques that I will show later in this video. So as we know with SOLIDWORKS, you always start with a 2D sketch. And so you always have to click a planar face or a plane. So whenever you start off a new part, it's always going to be a plane. And so in this instance, how I went about it, I'm going to push Control T once, that's Control Tom, T as in Tom. And what that does is it puts your design tree in a flat state. So when it's in a, I always mispronounce this, a hierarchy state, the sketch gets absorbed into the feature. But when you go into a flat state, it actually shows the sketch and then the feature. So it shows it as it technically was modeled within your SOLIDWORKS file. Okay, so I'm going to take this up to sketch 1. Sketch 1 is just a simple circle sketch that I made on my right plane, and it's a 3-inch diameter. Okay, so not bad. After that, I did a simple boss extrude. And with that boss extrude, I said take that 3-inch diameter and extrude it out an inch off of my right plane. Okay, so here's where the layer cake approach takes effect. I'm going to be making my next extrusion, but my next extrusion is going to be based off of this face and not the right plane. Okay, this is why they call it a layer cake. So if you've gone to a wedding or seen the, America's Funny some videos and so forth, you always see like the huge tall cake that topples over. Hopefully that never happens to you, but if it has, it might end up on YouTube or something, right? So this is where a SOLIDWORKS technician will consider this a layer cake approach. What they're going to do is build off of another face. So this is the base, and now we're going to build off from that. So sketch 2 is just a simple circle diameter sketch again. It's a 2-inch diameter. And then from there, we extrude that out 2 inches. So 2 by 2. All right. Then, continue on with our layer cake approach, I made another sketch based off of this face. And that's sketch 3, and it comes off at a 1.5-inch diameter. And we're going to extrude that out a 1/4 of an inch. Okay? And then sketch 4, I made that based off of that small face of that smaller circle. And with that one, I did a convert entities off of this last cylinder that I made off of Boss Extrude 2. And so I didn't have to give it a dimension because it's being driven off of Sketch 2. All right, and with that, we just simply extruded that one out 1 inch as well. Okay, so here's where the layer cake approach has its pros and cons. Pro to it, it's fairly simple. You just have to draw circles and you build off of the next face. That's a very simple process. One of the cons that some users will say is that, well, it adds a lot of features to your design tree. And, you know, whenever you click rebuild on SOLIDWORKS, it has to start from the very beginning of your design tree and go down each feature and rebuild it in that order. Because Cut Extrude 2 is dependent on Boss Extrude 1. Boss Extrude 3 is dependent on Boss Extrude 2, which is dependent on Boss Extrude 1. So that's why SOLIDWORKS starts from the top and builds its way down or rebuilds it. So some users will go, you know what, this isn't the best route because I have too many features in my design tree, and you know, the more features you add, the longer it takes to rebuild. Yes, that does happen. So those are some of the pros and cons to it so far, but one of the biggest cons that I see with the layer cake approach is utilizing your design intent. So let's just say for simplistic reasons, let's say that this shaft has to go inside of a hole, right? And that shaft, this whole shaft here, let's say it has to retain a full distance of 4 1/4. But let's say that this part here, the larger diameter, goes inside another hole, and then let's say a bearing rides on here, and then we have a lock, a retaining ring that goes here, and this is just extra material at the end. Okay, so let's say that's our scenario. So let's say that my hole that this goes into got a little bit shallower. Let's say it became 1/2 inch instead of 1 inch. So what do you think would happen when I make this from 1 to 0.5? Well, if I made it to a smaller dimension, am I going to have a gap that's going to show up here because that gets shorter? Or is everything that's extended based off of our base feature, is that all going to be shifted towards the left in this current view that we have? Well, let's find out. So I'll just simply take that 1 inch dimension and change that to 0.5. Do a Control Q on that. Oh, so this got skinnier, but did we still retain our dimension of 4 1/4? No, it dropped down to 3.75. Now, why did that happen? Well, it's because each of our 3D dimensions that we have here is based off of the existing face, the prior feature. So if we affect any of our prior features, it will affect the existing, the post features. Sorry, probably miscommunicating that. So does that make sense in that form where as you are affecting features higher up in the design tree and other features are dependent on it, it will affect those that are further down the tree. Okay, so that is a huge con to the layer cake approach, because I always say this as well, the more features you have to try to edit, the more likely you're going to forget one and you're going to make a mistake. For instance, let's say you're going at this and you're going 1,000,000 miles a minute, because let's face it, that never happens when you're trying to get a project done, right? So you're going at it and you're going, oh yeah, shoot, we need to make this so it's 1/2 inch, and I think we're good. I just updated it, we're good, right? Well, in reality, it's not good, because our whole shaft became 3 3/4 long instead of 4 1/4. So now I have to come in here and go, oh man, I need to come in, take that 2 inch and make it so it's 2.5 now, right? Do Control Q. All right, let's see if I come back to this and I fix this face, Sweet, 4 1/4, I'm back at it, right? Okay, I was able to catch that, but like I was saying, if you're going 1,000,000 miles a minute, right? Because a lot of engineers, that's how we are. We have to be trying to get projects out the door as quickly as possible, right? So when we are going that fast, it's sometimes hard to remember to update every feature, and we might miss one, okay? So that's why the layer cake approach can have a pretty detrimental aspect to it if you are not careful. Okay, let's look at the next approach. And by the way, if we go back to our assembly here, you'll see that my layer cake approach got updated. Cool. So let's look at the potter's wheel approach next. So potter's wheel, this is utilizing the revolve feature. And so that's why they call it the potter's wheel approach, because that's technically what a revolve is. You have an axis and the feature spins around it. Now, looking at this, one major pro to it right off the bat, based off of the existing feature that we just did, the layer cake, it only has one feature in here. So my rebuild time must be extremely fast, right? So that's not a bad function here, but let's look at it. This is taking one sketch to make. All right, pretty cool. So if I come into Sketch 2 and edit that sketch, it's okay, but I'm seeing a lot of dimensions here. You know, like I got that 2-inch dimension and that 2-inch dimension, that 1.5, 1 inch, quarter. Okay, not a big deal. It wouldn't be really hard to come in and be able to distinguish what dimensions are what. Like maybe I could clean this up and say, you know what, I always want this edge and this edge to always be collinear to each other. So I could delete that 2-inch dimension and say make these two edges collinear. And that would fully define my sketch as well. Okay, so there are ways that we could clean this up, but you know, this is a fairly simple part. And the sketch itself is fairly simple, but if we start adding more and more lines to this and dimensions to it, this can become a very complicated sketch very quickly. And so that is one con to doing a potter's wheel approach, trying to put every single sketch into one feature. Now, with SOLIDWORKS 2016, we are on SOLIDWORKS 2018, by the way, but when 2016 came out, 17 and 18 and 19 is even going to be better. That's coming out here this month, actually. SOLIDWORKS has found ways to make it so that your sketches, even if they get very complex and huge, can be fairly stable and not bog down your system as much. So SOLIDWORKS is finding ways to make your sketches not as daunting on the software now, and they're doing a phenomenal job at it. I'm still just one of those guys where SOLIDWORKS is a 3D modeling software. So I like to keep my sketches simple, you know, KYSS, KISS, keep your sketches simple. That's what I generally like to do. Now, granted, I'm a guy that came from board drafting and AutoCAD and DraftSite. Like I've done all the 2D drafting, and that's what I still do on a day-to-day basis. But whenever I'm working in SOLIDWORKS, I generally like to keep my sketches simple and let SOLIDWORKS make 3D features to make up my parts, because SOLIDWORKS is a parametric 3D modeling feature-based software. Okay, so that's why I try to let SOLIDWORKS, I try to stay within the parameters of what SOLIDWORKS is. Okay, so looking at this, let's say we had the same scenario. Okay, I know that my overall dimension on this guy is going to be 4 1/4. And SOLIDWORKS is going to pop up saying, hey, you're over defining this. Not a problem. I'm just going to say make this dimension driven. That way SOLIDWORKS says, oh, this is just a reference dimension. Not a big deal. Okay. You'll notice it's still black on my screen. That's because I went into my color scheme in SOLIDWORKS and I made it to where all reference dimensions or driven dimensions are black. Okay, so that's the reason why mine looks black still. Yours, if you do this, you'll probably see that yours becomes like a lighter gray color. So it's a reference dimension. It's just my color scheme, I made it black. All right, so looking at this, I want to make it to where we're going to have the same scenario where that 1 inch dimension now becomes 1/2 inch. So if I double click on that and say 0.5, you'll see everything else out here stayed the same. Why is that? Well, let's go ahead and take that back to 1. So when we did the layer cake approach, I made it to where there was a 2-inch dimension from this face to that face, right? Because imagine this as that circle that was extruded out 1 inch, and then I extruded off of this face to the next one. Well, by me going at this potter's wheel approach, I'm saying that my design intent, you know what, the shaft that this fits inside might vary. You know, it might not be 1 inch, it might be 1.5, and it gets updated. But it does not affect these other dimensions out here. The reason why is because of this 3-inch dimension. I came in and I gave it to rules saying, look, I want my groove here, you know, for my retaining ring to always be 3 inches off from my flat face here. So that makes it to where my groove and also my extended excess material on the end does not get affected by the dimension of whatever the hole that my shaft fits into. So this is a design intent, and this is a really good pro of doing the potter's wheel approach over the layer cake approach, okay? So that's just a dimensioning method that I like to do. So if I have a rule saying, look, I need these guys to stay in one area at all times, but my shaft might change for fitting inside of a hole, I'm going to dimension it that way. Okay, so it's all a part of design intent. Okay, and many, like I have the privilege of teaching at our local community college, SOLIDWORKS and AutoCAD. And when you're working with people that are new to the software, it's kind of hard to grasp design intent. And I know when I went through college and so forth, like I worked in the industry, but I didn't really work in industry. You know, I was like one of those interns. I never fully grasped design intent until probably like 6 months after I graduated college, and I started really going at it. Instead of taking other people's drawings and making 2D drawings off of them, you know, being a draftsman. So now that after graduating from college and so forth and designing parts, design intent totally made sense to me after that time. Okay, so moving along here, this is a very good pro to the potter's wheel. So once again, we are using 2D sketches to drive my parameters of my part. I am not affecting my overall design intent, saying that, hey, this has to be 4 1/4 and I don't want my groove out here to change at all. Okay, so pretty awesome actually to set it up that way. Now instead of doing that, instead of doing that 3-inch dimension, I could have also come in here and dimensioned off of this side and said, hey, it always has to be 1 1/4 off or something like that. That is another route that you could definitely go. Okay. All right. So now we got that set up. Let's go ahead and head back to our assembly, and let's see how we're going to look at the machinist approach as I am fumbling around here with my dimensions. All right. It's like chewing gum and walking, right? Pretty tricky. Okay. So going back to our assembly, like I was saying for the 5th time, we'll see here that this part has updated, but nothing else had to change. So it's a little more simple than having to come in and update several other features. Now let's look at the final approach with modeling this certain part within SOLIDWORKS, and it's called the machinist approach. So the machinist approach is you as a designer have to think of how is this part going to be made. And so this is a turned part. And so when I say it's a turned part, that means it's more likely going to be made on a lathe. And so you got to look at, okay, how is my machinist going to see this part starting off? Are they going to start off with, like, you know, my layer cake approach where it's just one piece of metal or plastic, and then, oh yeah, now they're going to add another piece to it, and then add another, and then add another on top of that? Not unless they're doing 3D printing. That's not how a standard machinist will look at a part like this. Instead, how they would really look at it is see this as a solid round stock. You know, in this instance, a 3-inch diameter. So they would look at it as a solid round stock. Okay? And they would take that, they would chuck it up in the lathe, and then from there, they would start making their passes to cut it. Okay? So going through this and cutting it, there are 2 ways that you can go about it. You could do the revolve cut feature, and that will work just fine on this. How I went about it is I just did standard extruded cuts on the feature on this body to remove material. So you could go either way on that. Both of them do work just fine. So with my extruded boss base that came out, now the next step that I did was I did a cut extrude. Now on this, I made it to where all my cuts come off of this right side face. Now the reason why I did that is because I'm saying, you know what, more likely they're going to chuck up this side here, okay? And so the tool is going to be coming across and cutting this way. So I made it to where they would cut, I would make SOLIDWORKS to cut off of the same face that they're going to be starting their passes and cutting onto this round bar stock. Now, looking at the sketch, I just did a simple diameter circle here and made it 2 inches. And with that 2-inch diameter, I told to cut, but I only had 1 circle. In case you don't know about this, you can flip your side to cut when you're doing a standard extruded cut. So if I don't flip it and just say okay to that, you're going to see that hollows out the inside. But when you say flip side to cut, it's going to take the opposite side of your sketch. So it's coming in here, it's taking the outside, everything on the outside will get removed. Pretty cool, right? So now that you say okay to that, next up, well, oh, and by the way, how I went about that cut is I told it to come in 3 1/4 because I made my, based off of our very first part, I made that so it's a 1-inch thickness, right? So I made it 3 1/4 depth. Okay, next up, what I did was utilizing the SOLIDWORKS features here, I did a plane, and this is where I was also saying where you could do like a revolve cut, because what we're doing is cutting out the groove for the retaining ring. So that plane 1, what I did was I came in and I made it to where it was 1 inch off of this face. Because once again, I'm trying to keep the same process where I'm machining off of that right face there. Okay, then from there, I just did another cut extruded 2. And with that, I did the same function where I just did a 1.5 inch diameter circle, just like all the other features. And what I did on there was I told it to flip side to cut, and I told it to cut 1/4 inch depth. So this is honestly the most common way that I manufacture like a revolved part in this instance. I look at, okay, how is my machinist going to take this? And I'm going to remove material as I cut. So looking at this, so let's say, oh, I need this to be from 1 inch to 1.5 inches. Okay, so looking at my cut extrude here, I'm now having to do some math where I say, all right, so it's at 3 1/4. So I need to now, let's add a distance to it so we can make this part skinnier. So that might get a little confusing, right? I need to make this longer to make that part a little bit shorter. That could be challenging, but also you could look at it in the sense of, hey, my machinist is going to travel from this face up to here at 3.25 inches, okay? So now you could say to him, hey, I want you to travel in just 3 inches. Now by doing that 3-inch travel, and you do the measure command, you'll see from this face to this face is now 1.25 inches. So your machinist might appreciate that, but this is where you kind of have to weigh the odds here and you go, oh man, I'm having to do math to figure that out. So instead, the other route that you could go about this is that instead of saying just do a blind cut, you could say I want to do an offset from surface, and the surface I want to offset from is this face here. And now with that, I can say, hey, I want it so it's a 1-inch offset. And so now what that will do is it'll make it to where this is 1 inch for me. Pretty cool, right? Now look what happens if I double click on Cut Extrude 1. You'll see that I got that 1-inch dimension. So now I can say, oh, I need it to be 1.5 inches. Control Q, rebuild, updated. Now are you noticing what's pretty cool about this? As I'm updating this, you're going to see that my groove over here is not changing at all, right? It's because I'm defining it all off of this right face here. It's not being defined off of this first face. Okay, so this is why I like using the machinist approach. Now, a con to it could be that, hey, you got 4 features in your design tree. Yeah, that can be a con as we are making more complicated sketches. But if you've watched some of the other YouTube videos that we have here, I did one talking about the freeze bar. It was on another Just a Thought Thursdays. Freeze bar is this thing at the very top of my design tree here. It's this orange bar. If I drag this down, SOLIDWORKS will freeze whatever features are above it. And it kind of like takes a screenshot or a snapshot of that given set of features and it won't affect them anymore. So if I do a rebuild, SOLIDWORKS is going to ignore everything above it and rebuild everything below that freeze bar up to your rollback bar. So enabling that freeze bar is a very useful tool. I always have it on. Once again, it's under your options if you haven't seen that YouTube video. And it's under options, and then from there, under the system options, general, it has a little checkbox here of enable freeze bar. So I always have that on. It's a great feature for as you are making more and more complex parts. Cool. All right, so let's go back to our assembly. So you will now see that my machinist and my potter's wheel look the same, right? I did not have to come in and adjust my design intent of, oh shoot, I need to make sure that I'm keeping that 4 1/4 as compared to my layer cake approach, right? So I hope you get an idea of seeing the 3 different ways of making that same part. And you'll hear people say constantly, hey, there are multiple ways to skin a cat in SOLIDWORKS, right? We don't want people to skin cats. That's not what this video is about. We are just, it's just a saying that people say, you know what? Yeah, there's multiple ways to make a single part in SOLIDWORKS. And honestly, you gotta look at it in the form of what is the best way to make this part to fit within my assembly and also to relay the information to my shop floor. Okay, so these are some of the reasons why there are different approaches. So once again, layer cake approach has its pros and cons. It's the most standard way of modeling. It's the easiest way of making a model. Cons to it though is that it has multiple features that will end up on your design tree. And also, if you come in and you edit like the very first feature, such as Boss Extrude 1, it will affect all the other features prior or post it. And so if you got design intent saying, hey, I need to keep a distance of 4 1/4 of an overall length, you might not want to use the layer cake approach. Okay. Next up of what I showed you was the potter's wheel approach. Pros to that is that it only takes 1 feature. A con to that, it only takes 1 feature, meaning that you're going to end up having a complicated sketch, possibly. Now, also looking at my sketch on this, I went in and I dimensioned it a certain way to where my groove and so forth was not affected by the depth of my, the depth of whatever this shaft fits in the hole on. So if I update that at all, it does not affect this, and also it will not affect my overall distance of this part, okay? And then the last one that I showed you was the machinist approach. The machinist approach takes a couple features, not too many though, but it does take a couple, and it's taking it as if the machinist is making this part. And it's going to be made on the lathe, so they're going to start off with a standard round bar stock, and then from there they're going to start cutting away material. And so that's how we made it. We came in, we said, hey, our overall distance is 4 1/4, so we know that is never going to change unless I came in with like some cut and I lopped off the edge. That might change it, but I'm setting up a rule that this is an overall distance of 4 1/4. Then from there, we just came in and did a standard cut. So imagine that tool coming in, kissing that face a certain distance in, and then that's cutting it. And then you got cut extrude 2, which is that standard little slot there. All right. So once again, my name is Peter Estes. I'm the owner of ValleyCAD. We are a mechanical engineering and product design firm. We also offer SOLIDWORKS consulting, as you can see here. We also offer 3D scanning and reverse engineering. You'll see we got a 3D printer in the back there. We utilize that for prototypes. We also have a tabletop 3D CNC carving machine. So yeah, we do a lot of services, and our goal here is to be your solution for when the designing gets tough. Okay, so hopefully you enjoyed this video. If you have any questions on it, feel free to hop onto our website. It's www.valleycad.com. On there, you can see all our contact information. If you call, more likely you're going to be calling me. Also, my email's on there as well. So shoot us an email if you got questions within SOLIDWORKS or if you got ideas for other videos. I love seeing that. Also, we're on YouTube, so please like this video. And also subscribe to the ValleyCAD YouTube channel so you can be notified when we do other live videos. Let us know how you like these live videos. Are they decent, or would you prefer that I try to make them a little more polished and do pre-recorded videos? I could do that as well. So once again, thank you so much for watching this video. Have a great rest of the day, and make sure you learn something new. See ya!